In this video, we're going to present an introduction to the Pydantic library in Python, and this is a library that's used for data validation and also for settings management in your Python applications. And it's very common and popular nowadays and used by a lot of big projects such as FastAPI. Now, Pydantic uses Python 3's type annotations in order to determine the data types of fields on a class that you define, and these classes are there to determine the structure of the data and the expected data types. In this video, we're going to use Pydantic to model JSON data that's coming from an external source, and we're going to be following along with a blog post that I've written here, and I'll leave a link below the video to this post. What we're going to do in this video is we're going to learn how to define Pydantic model classes that model the structure of our data. We're also going to learn how to use type annotations in Python in order to determine the data types of our fields. We're going to learn how to specify optional and constrained fields in Pydantic, and we're also going to learn how to write custom validation functions for particular fields on our models. And finally, we're going to learn how to export those models to JSON data or to Python dictionaries. So let's get started. Now here I have the blog post. As I said, I'll link that below the video, and we also have a data repository here on GitHub, which I'll also link below the video. Now in this data repository we have 3 files for student data. The first one is the one that we're going to work with in this video, so let's click that, and you can see the JSON fields that we have here. It's just a flat schema, a list of objects, and each one represents a student in our data set. And each student has an ID, a name, a date of birth, and some other fields. We're going to use Pydantic in this video to model this data with a class. Now, Pydantic is very flexible for working with data. We're going to see some of the ways that we can validate the data that's coming into our application from each of these fields, and also how we can cast it from one data type to another. Now, if we look at one of the sample records here on the blog post, you should note that there are a few things that we want to change about this data. For example, if we look at the GPA, it's a string with the number 3.0 in this case. We want to model this as a floating point number. We don't want it coming in from an API and represented as a string. We want to convert this to a numerical data type. We also want to take the date of birth that's coming through here, and we want to model that as a date rather than a string, and this will allow Python to do more complex work with that because it's represented properly as a date object. And finally, if we look at the course and the department, the course is a nullable field, it's optional. We want to model that in our data and say to the Pydantic model that we can consider this field to sometimes have data, but it's not required. And for the department field, which is this one here, we want to limit the permissible values to a small set of departments because a university only has a small set of departments. We don't want to allow any value for this field. We're going to see how to do that later in the video. So if we scroll down, what we need to do to start with is install the Pydantic library that we're going to use, and also the requests module. So let's go to VS Code, and you can create a virtual environment in Python, and you can run that command there. It's the pip install Pydantic and Requests command, and I've already done that in this environment. So if I run the pip freeze command, you should see that we already have these 2 libraries in the environment. Now we also have a file called main.py here. You can just create an empty Python file, and that's what we're going to use in this video. And what I'm going to do is go back to the blog post, and we're going to copy this code here and paste that into the main.py file. And what this code is doing is it's basically sending a GET request to our GitHub dataset, and it's pulling that data into the application and using the response.json function to convert that JSON data into Python dictionaries. So let's save this file, and then we can run python main.py in order to test this out. And you can see we get some data below here, and I'm going to remove the screen on the left there with the files, and you can see we get a data set with the ID and all the other fields for each student. So we're pulling that data into the application. What we now need to do is start modeling this data with Pydantic. So I'm going to remove the print statement from this section of the code, and just below the data here we're going to define a class here, and we're going to call that student. Now this class is going to inherit from a Pydantic model that's called the base model, so we need to import that at the top, and that's going to be from the Pydantic library. We're importing this base model, and whenever you're modeling data with a Pydantic class, you're going to typically inherit from the base model, and then within the class what we do is we define fields of data, and each field has a name and then it has a data type. So let's go back to our data set on GitHub here. We have an ID column first of all, or an ID field in this data. We're going to copy that and paste it into the Pydantic model, and that has a type of a UUID. If you look at the data, you can see that each ID is represented by a UUID. So we're going to represent the ID on our Pydantic base class as a UUID, but we need to also import that module from Python's standard library. So let's do that just now. And then down in the ID field, we can define the type of this as a UUID object. So you can see the structure here. We have the field name, then a colon, and the data type after that. So let's go to the next field in our data, and that's the name field. We're going to model this field, and that's a very simple one. It's just a string of data representing the student's name. And the data type for that field is just the string data type. So let's keep going. If we go to the next field, it's the date of birth field. So we're going to copy that and we're going to paste that into our Pydantic model. And this is going to be a date object. So at the top, from the datetime library, we're going to import the date object, and that is going to represent the date of birth. So when we create a Pydantic model from this data that we have coming from the GitHub repository, it's going to try and convert all of the date of birth fields to date objects. That's what's going to happen here, in the same way as it's going to try and convert the ID field to a UUID object. Now let's move on to the GPA. As I said earlier, we want to represent this as a floating point number, not a string. So let's go back to VS Code, and within our Pydantic class, we're going to create a field called GPA, and that's going to be a float. So this is another feature of Pydantic. What this means is that even though this is represented as a string in our external data, it's going to try and convert that to a floating point number. So Pydantic performs this type conversion based on the data types that you use in the model class, and we're going to do that for the GPA here to convert it to a float. Then the next field in our data is the course field. If we go back to GitHub to the dataset, you can see that this is a nullable field. It doesn't always have a value. When it does have a value, you can see that it's a string data type with the name of the course. So we need to model this as being nullable or optional in our data. Now, if you're using Python 3.10, it's very easy to denote an optional data type. It's normally going to be a string, but we can use this operator here, and we can say none here, and that's basically going to mean if it's not a string, we expect it to be a null value from the external data. And when you're doing typing with Python 3.10, this syntax here is a union of two types, and it basically means that the course, we expect it to be one of these two data types. And of course, if it makes sense, you can do any number of unions. You could have an integer here as well, and that would mean that we expect the course to either be a string, to be a null value, or to be an integer. In our case, we know it's going to be a string or it's going to be null, so we'll leave it like that. If you're using a version of Python that's less than 3.10, what you can do is from the typing module, you can import the union type from that module, and then you can specify this course like this. I'm just going to write this as a comment here. It would be the union of the string and the none value. So just separate the data types with a comma, and that's if you're using Python 3.9 or anything below that. So let's keep going. We have a couple of more fields in this. First of all, we have a department, and we want to limit that to a set of values. We're going to do that a little bit later on. For now, let's just say that that's going to be a string. And finally, we have a field that's called fees paid, and this is a simple Boolean field. It's going to be true or false, and we can represent that with the bool keyword. And this is a simple field that says whether or not the student has paid their tuition fees in this imaginary data set. So this is our first attempt at a Pydantic model. What we're going to do now is we're going to take this data that we've got back from the GitHub dataset, and we're going to try and convert each record in that data to a Pydantic student model. So let's go down here, and we're going to define a for loop here, and we're going to say for each student in the data, we're going to create a model for that student, and we're going to instantiate the student Pydantic base model, and we're going to unpack the keys and the values from the student that we're iterating over that comes from this data here. We're going to pass them as keyword arguments to the student model and instantiate that model. And finally, we're going to print that model out here below. So when we unpack the keyword arguments like this, what it's going to do is it's going to take each record from our data set. So for example, this is one record here, and it's going to pass the keys, for example, the ID field with a value of whatever the value is for that field. And it's going to do that for all the fields in the record. So we're passing a bunch of values to the student Pydantic model. Let's print this out and see if we get a valid result here. So we're going to run the python main.py command, and you can see this output below here. We're getting an output log of all the fields in the Pydantic model. And importantly, if you look at these fields, for example, the date of birth field here, you can see that that's an instance of a date object. It's no longer a string coming from the API. It's been converted successfully into a date object. and that's true for all 5 records in this source data. And also, as you can see, the ID field has been converted into a UUID object. So Pydantic is performing these validations, it's performing these type conversions for us, and it's doing that based on the data types that are defined on the base model subclass. And you can see as well, if we look here at the GPA field, that is now represented by a number, it's not a string in this data, and that's because we've specified the float data type for the GPA, so it's doing that conversion for us. And this is very convenient when we're modeling data, and of course if we don't know for sure what the data type is, we can always use these union types, and that will then try and convert that particular field to each of these data types defined in the union until one of them successfully converts. So let me make the terminal a little bit smaller. This is the first key point of this video. We can use Pydantic to define the fields that we expect to have in a data set that we're bringing into our application. And for each field in that data, we can specify a data type or a union of data types. And Pydantic will then try and convert the source data to each of these types. And that gives you some basic data type validation for each field. And it can convert things like strings into datetime or UUID objects. And of course, this particular union here, this is an optional field. The course might be null in the data, so we specify a union of the data type we expect, which is a string, and the none type. Now I've mentioned here that this in Python 3.9 and below is a union of string and none. There's also another way to define that, and that's using the optional construct from the typing module. So you can also use that if you want, but I would recommend that you try this out with Python 3.10, and you can use this new operator that we've got here. So that's the first part of the video. Let's move on to something new here. In the blog post, there's a section on constrained types. So there's an example in the post here. Imagine we have a user model, and this is using the Pydantic base model. It's defining a subclass of that with 2 fields, a name, which is a string, and the age field, which is an integer. Now you can imagine that users will sign up to an application and they'll specify their current age at the time of sign up, but the age field should not allow any random integer to be input because, as you know, most people cannot live past the age of, let's say, 130, and also the age cannot be negative. So what we can actually do here is define constraints on what values are accepted by the Pydantic model for this particular field, the age field, and these are known as constrained types. So that means if someone's signing up to our application, they try and put in an age of 2000, we can write code in the Pydantic model to reject that sign up and throw a validation error because that age is not within the boundaries of what's expected for that field. Now you can see that Pydantic has some of these fields built in. There's a constrained integer type, and we also have these constrained fields for floating point numbers, for strings, for lists, and for other data types. So if we scroll down, we can see a revised implementation of this user class where the age field is defined with a data type of conint, and that's a constrained integer that has to be greater than 0 and less than 130. And if we use dummy data here, we can see that if we create a record where the user's age is 50 and we create a Pydantic model based on that data, that's totally fine because it's within the boundaries of that constrained integer. But if we try and create another user whose age is 150, that will throw a validation error because U2's age is beyond the limit for that particular field. So this is what we use constrained types for. Let's now use it in our own code for the student model. If we scroll down here, you can see that what we're going to do here is for the GPA, we're going to define a constrained floating point number that has to be between 0 and less than 4, or rather it has to be greater than or equal to 0 or less than or equal to 4. But what we're going to do is copy this constrained float and we're going to paste that into our Pydantic base model and replace the ordinary float with the constrained float, and we need to import the con float from Pydantic at the top here. So let's paste that in, and if we rerun the main.py file now that we've changed that to a con float, we should hopefully see the same results, and that's because every student's GPA falls between 0 and 4, so no validation errors will be thrown for that data. But we can test this out by actually copying one of the fields from the data set here. So I'm going to copy the top field that we have at the top of the data set, and we're going to paste that into this file here. Now at the top we have the data that we've got from the API, or rather from GitHub. We're going to append to that a new record that we're pasting in from GitHub here, and what we're going to do is we're going to change this to false, and we're going to change the GPA to 5.0. That falls outside the boundary for what's acceptable for the GPA field based on this new con float that we've defined. So if we now try and rerun this with our new data, you can see that we get a validation error. So I'm going to expand this, and we can see that we have a validation error for the student, and it's the GPA field. We need to ensure that the value is less than or equal to 4. And because we've defined that value with the number 5.0 here, it's rejecting that and it's throwing a validation error back to us. So we cannot create a valid Pydantic class based on this data because one of the fields does not have a value that's acceptable to Pydantic based on the constraints that we've defined in the model. So that's just demonstrating a constraint type. Let's delete this data field that we're appending here and save the file. You can imagine that we might want to write other constraint types here. For example, the date of birth. We might want to constrain that and make sure that students are above a certain age before they try and enroll at this university. We're actually going to see a different way to achieve that in just a second in this video. So let's move on now. And what we're going to look at next is custom validator functions. Now we have this basic validation of each field. For each field we're giving it a data type that we're expecting or a union of data types. And now we've learned that we can also expand that to include constrained types. For example, for the GPA, to constrain the value between two numbers. What we're now going to do is we're going to constrain the date of birth, and we're going to make sure that students are above the age of 16 and that any student record coming into this data and being modelled by this class will reject any student whose age is below 16. So what we're going to do is at the top, I'm going to import from Pydantic another function, and that's the validator function. And this validator function is used to define custom validation functions for fields on your Pydantic models. So what we're going to do is go down here below the field definitions, and we're going to define a decorator using that validator function. And to that we pass the name of the field that we're defining this validator for, and that's the date of birth field. And then we can write the function that is going to perform the validation logic here, and we're going to call this function ensure 16 or over, and that takes two arguments in this case. The first one is the class itself, and the second is the value that's being passed to the model for that particular field. So the value is going to be for each record equal to the value that we actually have for the date of birth in our external data source. So for the first one it's going to be this one here in 1995 and so on. So the value is passed into the function when we decorate that particular field with the validator function. And now we can write the logic to ensure that the age that we're getting is above the age of 16. So what I'm going to do at the top is from datetime, we are already importing date. I'm also going to import the datetime function as well as the time delta. And we're going to use these down in our validation function. And I'm going to define a variable called 16 years ago. And that's equal to the current datetime minus a time delta of 16 years. So that gives us back a datetime object. We need to convert that to a date so that we can do a comparison with the date of birth field, because that object is a date as well. So we need to convert datetime to date. We do that by saying 16 years ago is equal to that same value, and we use the .date function, which is defined on a datetime object, to convert it from datetime to date. And now that we have two date objects, we can use the value that we're getting from our external data, and we're going to say if the value that we're getting from our external data is greater than 16 years ago, that means the student is younger than 16 years old, and we're going to in that case raise a value error. And in that value error we can define a string that we're going to see on the console, and we're going to just say too young to enroll and an apology, and then we can just return the value if we don't get that value error. That means that the date of birth is valid, and we just want to return that and continue the field validations in our Pydantic model. One thing to note, and you're going to see this in another video soon, the Pydantic field validations run from top to bottom based on the order that you define the fields in your class. So for us, the date of birth is going to be the third field after the name and the ID, and that's going to run this, and then once it returns the value it's going to continue to the GPA field. However, if we raise a value error, then obviously we're not going to create a student model because there's a value error, something's wrong with the data, and therefore we're going to get a validation error. So let's clear the terminal now, and I'm going to expand this terminal and we're going to rerun the Python main.py. And you can see that all records are passing here, and we're getting back Pydantic models for each record in our GitHub dataset. Now we can again add another record to this data with the data.append function. And I'm going to copy some code from the blog post here, this record here. And you can see importantly that the date of birth here is defined in 2010. So that's only 12 or 13 years ago from the time of recording. So if we clear this and rerun the code, we're now going to see that we get this error here. And we get the message that we defined in the value error, too young to enroll, sorry, and that's for the date of birth field. So you can see that it's running our validation function here that we define with the validator decorator, and it's calculating that logic based on the value that's being passed in from the student record. If the student's too young, we get a value error. If not, we simply return the value and continue with the validation. So that's how we can define custom validator functions. There's a good section of Pydantic's documentation on validators. I'll give a link to this below the video. You can see how a validator is defined here. Again, it's defined on a particular field on the Pydantic model, in this case the name field, and you can define any logic you want in Python in this function that will then determine whether or not the value is acceptable or whether it should be rejected and throw a validation error. Now we're going to see later on how we can do more complex things with validators. For now we're going to move on though to something else. What I'm going to do is go to the blog post, and we have a section on how we can use enums in Python as the types for fields in our Pydantic model. So if you remember, we have a department field in our Pydantic model, and at the moment that has a data type of string, and this is fine because all departments actually are strings. But what we're going to do is constrain this to a small number of possible values, and we're going to use an enum here in order to do this. There's also another way to do this with the literal type in the typing module in Python. We're also going to see that in another section of the video or in a future video. But what we're going to do for now is I'm going to copy this enum and we're going to copy it into our file here. Actually, let's define a new file for this called enums.py, and we'll paste that in here, and we have a department enum, and there's 3 departments within this enum. We have arts and humanities, we have life sciences, and we have science and engineering. So what we're going to do is copy this enum and we're going to import it into our main.py at the top. So from enums we can import the department enum. And what I'm going to do now is remove this extra record that we appended to our data, and we're going to save that file. Now what we can do is go down to department. This is a field on our Pydantic model, and instead of defining that as a string, what we're going to do is we're going to use the department enum in order to constrain it to one of those values. So let's expand the terminal, and we're going to try running this code once again. If I run main.py, you can see that we get results here, and now the department is not a string. It is referencing the department enum and one of the values on that enum. In this case, the top one has the science and engineering. So again, we have a field on our Pydantic model. This time it's department, and this has a custom enum type called department enum, and we can use that to take the incoming data from an external source, and we're coercing that to one of the values defined here in this department enum. So Pydantic works really well with all of these different constructs in Python. For example, UUIDs, it works natively with that object. It can work with dates as well as date times and time deltas, and it can also work with enums and literal types. We've also seen how to define constrained types where the value has to conform to particular rules that we define. In this case, we have a numerical constraint type where the value has to be between a lower and an upper boundary. And finally, we've seen how to define optional or union data types where the value can be optional. It might be null, or it might have a particular type, and also it might have a number of different types. Now the last thing that we're going to do in this section is we're going to take this student data type and we're going to export that to a Python dictionary that we could then pass around our application and use in any way we'd like. Now it's very easy to do this. If we scroll down to the bottom, we have a model here. For each record in our data, we are passing those fields and values, creating a Pydantic model. And what we can do is, to the model, we can call the .dictionary function, .dict. And if we save that and execute this code, you can see that now the output is actually Python dictionaries now instead of Pydantic model classes. And each dictionary has the key, for example ID and name, and the values are what's coming from the model after all the validations. So the workflow for this at the moment is that we take data that's coming from an external source such as a website or an API, we model it with Pydantic, and we define data types for each field in the data. We can also optionally add custom validator functions and custom constrained types. Once that data is into our application and it's in a Pydantic model, we can then export the data from that model to a dictionary, and that dictionary, as I said, it contains the values that have been validated. For example, a UUID object for the ID. Now what we can also do is convert this to JSON data. Instead of the .dict function, we can simply call .json. If we execute that, we are going to get back JSON data for this. Now this is a bit different, as you can see. It looks like Python dictionaries in the terminal, but it's actually done the conversion from the more complex data types like a UUID. That's been converted to a string that's then ready to be sent over the network, because obviously strings are well understood by JSON, whereas a UUID object would need to be serialized, and that's exactly what Pydantic has done here. So it's smart enough to serialize the complex data types like a UUID and also the date of birth, as you can see as well. It's converted them from the complex objects to the simple string that's then transmissible over the network. And it's done the same for the department. Instead of an enum, which JSON does not understand, it's converted that to the raw value, which, as you can see in our enum class, that's also a string. So that's the key difference between the .dictionary function and the .json function. The dictionary function will simply dump the data to a dictionary with all the complex data types, and you can then use that in your Python application in any way you want. Whereas with the .json function, it's going to take those complex values and it's going to boil down the complex data types to simple primitives. So these are two of the main ways of taking your Pydantic models and converting them to other representations that you can use in any way you want. So that's all for this video. Let's go back to the blog post, and here is the summary of this video. We've introduced some key concepts in Pydantic. We've learned how to create model classes. We've learned how to annotate fields in that model with types, and these can include complex types such as unions and optional types, as well as constrained types where the values have to conform to a set of rules. And we've also learned how to define custom validation functions using the validator decorator that's provided by the Pydantic library. We learned also how to define very simple enums, as you can see here, and then reference them as the type for a field in our Pydantic model. And finally, we also learned how to export data to a dictionary and export data from our model to JSON. Now I've got 3 more videos planned based on posts that I've already done. The next one we're going to cover nested models, and that's going to cover how we might have complex types within our Pydantic models. For example, if we look at the next section of the data, this version 2 here, you can see that instead of just a flat record for each student, we're introducing a modules key here that references a list of objects, and this object here will also need to be modeled by Pydantic. So that's going to involve nesting our models in some way. We're going to look at that in the next video along with some other concepts. And one of the other things we're going to look at is how to create JSON schemas from our Pydantic models, and also how we can take an existing JSON schema and use a tool called Data Model Code Generator to create Pydantic classes based on that JSON schema. So we're going to see all of that in the next video in this series. But that's all for now. Thank you for watching. I hope you've enjoyed the video. If you have, please like and subscribe to the channel, and we'll see you in the next video.